In the next question, we have which one of the following statements is correct with respect to the redox reaction. MnO4 minus reacting with ferrous oxalate in acidic medium to give manganese ferric ions plus carbon dioxide plus water. So 1 mole of MnO4 minus oxidizes so many moles of ferrous oxalate, and stoichiometric coefficient of MnO4 minus equivalent weight of ferrous oxalate, 1 mole of ferrous oxalate reduces. So these options given can be checked correct or wrong by first balancing the equation. Thereby we have the equation here as MnO4 minus permanganate ion reacting with ferrous oxalate in acidic medium to give what? Manganese ion Mn2 plus, ferric ion Fe3 plus, carbon dioxide CO2 plus water. So here permanganate, manganese is plus 7 and here manganese is plus 2. So the difference being 5, the multiple 5 is to be placed here. And whereas it is ferrous oxalate, ferrous plus 2 is getting oxidized to plus 3. So change is 1, n factor with respect to this is 1. Whereas oxalate ion is giving carbon dioxide, where in oxalate ion carbon is plus 3 state, carbon dioxide carbon is plus 4 state, and the change we find is plus 3 to plus 1, but there are 2 carbon atoms, so net change will be 2. So the n factor we can write here with respect to this is 2, but both ferrous and oxalate are there in the same substance, ferrous oxalate, so the net change is 3. Nf is equal to 1 in this case and 2 in this case, total change is 3. So therefore that 3 is to be placed before permanganate ion. So it is 3 MnO4 minus. And now balancing manganese, iron, carbon dioxide on the right hand side by taking into these stoichiometric coefficients into account. 3 MnO4 minus. So this is 3. 5 iron atoms. So 5. 5 into 2, 10 carbon dioxides. From where we can understand that every 3 moles of permanganate oxidizes 5 moles of ferrous oxalate. That is, every 3 moles of permanganate MnO4 minus oxidizes 5 moles of ferrous oxalate. And in this, permanganate is an oxidizing agent, whereas ferrous oxalate is reducing agent. That is, 3 moles of permanganate when oxidizes 5 moles, 1 mole will be oxidized by, because in the option A, 1 mole of MnO4 oxidizes 3 by 5 moles of ferrous oxalate is given. Therefore, 1 mole of permanganate oxidizes how many? So we will get 1 by 3 into 5. In other words, 5 by 3. But what is given in the option A? 3 by 5. Therefore, option A is wrong. And option B says stoichiometric coefficient of MnO4 minus is 5. But what we got? Stoichiometric coefficient of MnO4 minus as only 3 we got. But here is given as 5. So B is also wrong. Then what about C? Equivalent weight of ferrous oxalate is 1 by 3rd of its molecular weight. So we need to see the n factor. In the case of this ferrous oxalate, the net change we could find, that is n factor as 3. So when the n factor is 3, equivalent weight will come out to be molecular weight by 3 only. What is given also same, equivalent weight of FeC2O4 is 1/3 of its molecular weight. N factor being 3, molecular weight by 3 must be equivalent weight. So therefore C is the right option. But what is the D given to cross check whether it's right or wrong? 1 mole of ferrous oxalate reduces 5 by 3 moles. From the stoichiometric coefficients we have 5 moles reduces 3 moles. That is, 5 moles of ferrous oxalate reduces 3 moles of permanganate from the stoichiometric coefficients. Therefore, 1 mole of ferrous oxalate reduces how many moles? So we'll get 1 by 5 into 3. So 1 mole of ferrous oxalate reduces how many moles of permanganate? We get 1 by 5 into 3. That is 3 by 5. In the D option, are we given 3 by 5? It is given as 5 by 3. Therefore, D option is wrong. So the answer is C.